Hello friends, with the new topic of fluid mechanics from fundamentals of physics. In this topic we have to study the definition of fluid pressure density, then we will see the derivation which is related with the variation of pressure with the depth in a fluid when it is at rest state, and different apparatus which are useful for the measurement of pressure, different units which are useful to measure the pressure and their interconversion, different types of flow. Then we will go for the equation of continuity, the definition for the viscosity. In this we have to study the velocity gradient too, Newton's law of viscosity. Then we will go for the coefficient of viscosity. To measure the viscosity of a given liquid, we require the Ostwald viscometer. In this we will study the construction and working of Ostwald viscometer. The last topic is the relevance to the life science of viscosity. Fluid. It is a substance which can flow or take the shape of a container. So from this we can say that the liquid and gases are the example for the fluids. Density. It is a measure of how much matter it occupies a given amount of space, and it is denoted by rho, which is equal to mass upon volume. Its SI unit is kg per meter cube. Pressure is the force applied perpendicular to the surface of an object per unit area over which that force is distributed. Pressure is given by force upon area. Its SI unit is Newton per meter square. Pressure is a scalar quantity. It is measured in terms of Pascal, Newton per meter square, or atmospheric pressure, torr, mm of Hg are also useful to measure the pressure. For the derivation of variation of pressure with the depth, you can refer the given link. With the help of this equation, which is given by P2 is equal to P1 plus rho g y1 minus y2, we can determine the pressure within a liquid or outside the liquid. For the measurement of pressure, there are two different apparatus are useful. One is mercury barometer, which is useful to determine the atmospheric pressure, which is given by P0, and the another one is open tube manometer, which is useful to determine the gauge pressure, that is Pg. What will happen? The mercury level will go down. Suppose within the tube the mercury level is denoted by level 2, and at the petri dish it is denoted by level 1. The mercury vapor, due to mercury vapor, the pressure above level 2 is 0 at ordinary temperature. With the help of mercury barometer, we can determine the atmospheric pressure P0, which is equal to H rho g. For its complete derivation, you can refer the given link. Next is open tube manometer, which is useful to determine the gauge pressure, which is given by H rho g. In this, we require a U-shaped tube which is open from one side and the another end is given to the container, for which we have to determine the gauge pressure. For its derivation, please follow the link. Flow. In the flow, what is steady flow? For the steady flow, we will consider a cylinder which is having length L and cross-sectional area A. If the input flow and the output flow is same, then it is said to be a steady flow. Rate of flow. How to determine it? It is a liquid volume that flows out across a known cross-section area per second, and its value is given by L into A divided by T for a given time T. But we know that L upon T is nothing but the velocity, so it is replaced by V dot A. A is the area of cross section. Different types of flow. Flow is of two types, streamline and turbulent. So first one is streamline flow. If I consider a layer of a liquid given by ABCD, then at a particular point A, the velocity is given by V1, at B it is V2, at C it is V3, and at D it is V4. For a streamline flow, it is not necessary that V1 is equal to V2 or they are equal to each other. But When the another layer comes to the same points, the liquid or the particle will follow the same velocity. The velocity of every particle of the liquid at a particular point will remain same for a streamline flow, both in terms of magnitude as well as in direction. It follows the same path. If we draw the tangent at that particular point, then we will get the direction of flow. The velocity may be differ. As I told you, v1 is not necessarily equal to v2. Means velocity at different point may be differ. But at a particular point, it will remain fixed or constant. Next, we will go for the turbulent flow. When the velocity of fluid exceeds its critical value, the flow changes from streamline to turbulent flow. The velocity here changes in both direction as well as in terms of magnitude from particle to particle. So we get the zigzag flow in turbulent flow. Next is the equation of continuity. Here we can have different derivation which is related with the fixed density and variable density. For the equation of continuity which is related with the fixed density, you can follow the given link. Our next topic is the viscosity. Viscosity, if we are talking about the liquid or a fluid, then we should know about the viscosity. It is nothing but the property of a liquid which oppose the relative motion between its adjacent layer. Okay, and this is due to the viscous force. What is viscous force? Viscous force is nothing but the backward dragging tangential force between two adjacent layers. So to overcome this, we required some external force. As shown in the PPT, which is more viscous, water or honey? When the fluid which is in contact with the surface, we have seen that it will have minimum velocity. The layer which is at the center or which is away from the surface will have maximum velocity. This is nothing but the velocity gradient. Velocity gradient is defined as the variation in velocity among the adjacent layers of the fluid. If we draw the graph of distance versus velocity, then we can see that as distance increases from the surface of a tube, the velocity also goes on increasing. And its slope, that is dv by dx, is nothing but the velocity gradient. Now, Newton's law of viscosity. It states that the shear stress between adjacent fluid layers is proportional to velocity gradients between the two layers. We know that shear stress is denoted by tau. So it is directly proportional to velocity gradient. As we have seen in the last PPT that velocity gradient is denoted by dv by dx. If we remove the proportionality sign, we will get the proportional constant eta, and that is nothing but the coefficient of viscosity. We know that the shear stress is given by F upon A, that is force upon area. So we can derive eta from that equation, that is eta is equal to F upon A dv by dx, where eta is nothing but the coefficient of viscosity. So we can define it as the tangential viscous force per unit area required to maintain a unit velocity gradient between two parallel layers. If we find out the dimension will be m1 L minus 1 T minus 1, and the coefficient of viscosity is measured in terms of Newton second per meter square, which is the MKS unit, and dyne second per centimeter square is the CGS unit. Now, to find out the amount of liquid which is flowing through a tube, we can use a POISEUILLE'S equation. With the help of this equation, we can determine the velocity of the liquid which is flowing through a tube, as well as we can determine the volume of a liquid which is flowing through a complete tube. For this, we have considered the tube AB having length L of radius small a, and we have considered or we have imagined a concentric cylindrical layer having radius small r. Due to pressure difference at A and B, the liquid can flow from left to right. For its derivation, you can refer the given link. Now, to measure the viscosity or to determine the viscosity of a given fluid, we have different types of viscometer which are given in the PPT. But out of this, in your syllabus, they ask for the capillary viscometer. Capillary viscometer is nothing but Ostwald viscometer. It consists of a U-shaped manometer tube having bulb on both the sides. Ostwald viscometer consists of different size of tubing. The side with the smaller tubing is referred to as a capillary, and the bulb is located towards the top of the capillary side. On the wider diameter side, a slightly larger bulb is located towards the bottom. Now, what we have to do? Just we have to pour the liquid on the left side, and by applying a pressure we have to take that liquid towards the right side above level H1. Then we have to record the time which is required to flow liquid from H1 to H2. Force causing the liquid to flow down is a pressure difference, and that pressure difference is given by H rho 1 G. What is rho 1? Rho 1 is the density of the liquid which is poured. Okay, now force which resists the downward flow, that is viscous force, and it will depends on the viscosity of the liquid. Therefore, the time T1 for a given liquid is directly proportional to eta 1 upon H rho 1 G, where rho 1 is the coefficient of viscosity. Then we have to take the another liquid with different viscosity coefficient and with the different density. So from that we can determine the T2 value. If we take the ratio of T1 is to T2, then the value will be eta 1 rho 2 upon eta 2 rho 1. From this we can calculate rho 1 upon rho 2. So if rho 1 we have to calculate, then we should know the other quantities such as T2 is directly proportional to eta 2 upon H rho 2 G. From this we can find out the T1 by T2, which is equal to eta 1 rho 2 upon eta 2 rho 1. From this we can go for rho 1 into T1 upon rho 2 into T2, which is equal to eta 1 upon eta 2. If we want to calculate eta 1, we should know the other quantities. The last topic is the relevance of viscosity to the life science or to our daily life. Viscosity is one of the key indicator of a quality of a fluid, right? So it is useful in medicine as well as in lubrication in vehicles, which we are using in our daily life. It is also useful in cooking and manufacturing. Thank you.